Hi everyone, today we're having the video for AP Review 14. Okay, and curiously, the first problem is number 2. And number 2 says if f is a function, and this is without calculator, 300x minus x to the third, on which intervals is f increasing. So we want to know when f prime is greater than 0. That's f prime equals 300 minus 3x squared. And so if I set that equal to 0, 300 minus 3x squared, I get 3x squared equals 300, or x squared equals 100, so x equals plus and minus 10. So I do plus and minus 10, negative 10, positive 10, and I look at my f prime. It's a downturned parabola, so it must look like this. So we've got negative, positive, negative. And we're looking for when is this function increasing, so I'm going to say negative 10 to 10, and that is choice B. Okay, problem number 1. Problem 1 says if y equals x sine x, then dy dx equals what? Well, this is product rule, so y prime is going to be 1 times sine x plus x times cosine x. Sine x plus x cosine x is our answer, and that is sine x plus x cosine x. Our answer for number 1 is B. B for number 1. Number 3, off to the side there, the integral of secant x tangent x dx. Well, we recognize that derivative. That's the derivative of secant x plus c. And so our answer is A for number 3. What about number 4? Number 4 on the right is if f equals 7x minus 3 plus ln of x, then f prime would be 7 plus 1 over x, and f prime of 1 is going to be 7 plus 1, or 8. And so E is our answer to number 4. Let's take a look at 5 at the bottom of the page. There's a graph above, the graph of f above. Which of the following statements is false? Okay, the limit as x approaches 2 exists. That's true. We are definitely approaching the same y values from both sides here. The limit as x approaches 3 exists. Yes, we're approaching the same y value from both sides here. The limit as x approaches 4 exists. No, we're approaching one y value from the negative side and a different y value from the positive side. That limit does not exist, so that statement is false, and therefore 5 is choice C. C for number 5. Okay, what about problem number 6? 6 says particle moves along the x-axis. V is 6t minus t squared. And we want the total distance traveled on 0 to 3. Well, let's think about this graph. 6 minus t times t. Velocity looks like this. And we're going on 0 to 3. So we want total distance traveled, which is just the straight integral of 6t minus t squared dt. From 0 to 3. The antiderivative of 6t is 3t squared. The antiderivative of t squared is t to the third over 3. And we're going from 0 to 3. 3 squared is 9. 9 times 3 is 27. And 3 to the third is 27 divided by 3 is 9. And I plug in zeros and I get 0. And so I get 18 here. And that's choice D. D for number 6. How about 7? 7 says it's time to use chain rule. Y equals x to the third minus cosine x all raised to the fifth. So y prime with chain rule, bring down the 5, leave the inside alone, subtract 1, times the derivative of the inside. The derivative of x to the third is 3x squared, and the derivative of minus cosine is plus sine. So there's our y prime, 5x to the third to the fourth, times 3x squared plus sine x, and that appears to be choice E. Choice E for number 7. How about 8? I have a note here that says 8 is with calculator. And based on the decimal answers, I agree. And so I don't know why this is. Oh, I know why, because it's just a Riemann sum. And so I'm saying you should do this with calculator, because really it's a pain in the butt to add up these decimal things and to multiply with decimals. But here's the setup. We're doing a right Riemann sum to approximate how many are in F15, and we know how many are at 4. So the amount at 15 minus the amount at 4 equals the integral from 4 to 15 of r of t dt. So I have to add the amount at 4 to that integral to get the amount at 15. So that's going to be 50 plus this integral from 4 to 15 of r of t dt. Now that integral they want me to represent with a right Riemann sum, so that's going to be 7 minus 4 times the height on the right side, 6.2, plus 12 minus 7 times the right side, 5.9, plus 15 minus 12 times the right side, 5.6. And so here I'm looking at 3 times 6.2 is 18.6. And then I've got 5 times 5.9. And this is why I say use a calculator, because 5 times 5.9 is going to be tedious and workful. And 29.5. And then here we have 3 times 5.6. And that's going to be 16.8. 16.8. And then I want to add up all these, so I've got 10, 40, 10, 30, 40, 55, 63, 64.1, 64.9, 114.9, I think. And that's choice C for number 8. Yes. Okay. Number 9 says f is this curiously defined piecewise function. We want f to be continuous at 2. Okay, so then the limit as x approaches 2 of f should equal f of 2. Well, f of 2 is k, and the limit on the other side is the limit as x approaches 2 of 2x plus 1, and then we have our x minus 2 and our x minus 2. Those cancel. I plug in my 2 and I get 5. K equals 5. And that corresponds to choice E for number 9. E for number 9. How about problem 10? 10 says the area of the region in first quadrant bounded by e to the x over 2 and the line x equals 2. So this is e to the x over 2. So I'm looking for this area, which means I want the integral of e to the x over 2 dx from 0 to 2. If you're not comfortable with the antiderivative here, you can always do a u substitution where u equals x over 2, du equals 1/2 dx, so dx equals 2 du. So this becomes e to the u times 2 du, or we can pull that 2 out in front. And how about some u-bounds? I'm going from 0, I plug in a 0 here, I still get 0, and I plug in a 2, 2 over 2 is 1. The antiderivative of e to the u is e to the u, and I'm evaluating from 0 to 1. I plug in a 1, I get 2e. I plug in a 0, not 0. E to the 0 is 1, so 2e minus 2. 2e minus 2, and that corresponds to choice A. A for number 10. Let's take a look at 11. 11 says f is the square root of this absolute value function. But no idea. Which of the following statements must be true? Yeah, no idea. Well, I know I can't take the square root of a negative, but luckily absolute value means everything in here is going to be positive. So the domain is all real numbers. I know that's true, which means I can plug any value in and get a number out. Even plugging a negative number in here. So negative 7 minus 2 is negative 9. Absolute value of negative 9. Positive 9. So yes, this function is continuous everywhere, but what about differentiable? Well, when I think about differentiability here, I think that I've got a problem at x equals 2 because of that square root function. That square root function says I could do a one-sided derivative here, but I can't use the limit definition of the derivative that says to come from both points. Just out of curiosity, you know, we're supposed to be able to do this, I understand, without, but let's just see what this graph looks like. Math, absolute, oops, I'm over here. Math, absolute, x minus 2, close parentheses, and zoom 6. So the function exists everywhere, but we really do have a pointy point there. The limit of the slopes is not the same. So there's 2, and this is our graph, and we say the limit as x approaches 2 from the negative of f prime doesn't equal the limit as x approaches 2 from the positive of f prime. So I'm going with choice A on this one. All right, that's A for number 11. So next page, problem number 12. 12 says u equals square root of x. Well, that was nice of them to give us the u. And here the integral e to the square root of x over square root of x dx. Well, our du is 1/2 x to the minus 1/2 dx. Or du equals 1 over 2 square root of x dx. I see a 1 over square root of x dx, but I don't have that. So I'm going to multiply both sides by 2. 1 over square root of x dx. And so then this integral becomes e to the u times 2 du. I'll pull that 2 out in front. And let's take our u bounds, which were originally 1 and 4, and plug them in here. I plug in a 1 here, I still get a 1. But I plug in a 4 here, and now I've got a 2. And so the antiderivative of e to the u is e to the u from 1 to 2, and don't forget that 2 out in front. So we've got 2e squared minus 2e. And that, oh, well, I went too far. 1 to 2, 2e, 1 to 2. That's C. Choice C. Okay. 13. If f is defined by this piecewise function, 2 for x values less than 3, and x minus 1 for x greater than or equal to 3, here's 3. 3 minus 1 is 2 with a positive slope, and 2 for values over here. Okay, so I have an idea of what f looks like. This is why we spent so much time in the last 2 years building a graphical sense so that you could quickly understand what's going on here. And we want to integrate from 1 to 5. Well, that's going to be this square. The height is 2, the width is 2, so that area is 4, plus the area of this rectangle. If I plug a 5 in here, 5 minus 1 is 4. If I plug in a 3 here, 3 minus 1 is 2, and this distance is 2. So we get 1/2, 2, 2 plus 4, or 6. The total area from 1 to 5 is 4 plus 6, or 10, and that's why choice D is my answer for number 13. Okay, 14. 14 says, if f equals the square root of x squared minus 4, and g equals 3x minus 2, then f of g of x, the derivative of that, is going to be h prime equals f prime of g of x times g prime of x. Okay, so let's find the derivative here of f prime. F prime of x is 1/2 x squared minus 4 to the minus 1/2 times the derivative of the inside function, 2x. These cancel, and we're left with x over square root x squared minus 4. That's f prime of x, but I want f prime of g of x, which means I need to take this and plug it in for each of those x's. Alright, so now I'm going to have, wow, and this is without calculator. Okay, wait a second. I don't have to do all that work. Just 1 second. Let's take g prime first. G prime equals the derivative of this linear function, which is 3. Okay, now what do I need? I need f prime of g of 3 times g prime of 3. Well, g of 3 means I plug a 3 in here, and I get 9 minus 2 is 7. And that means I want f prime of 7 times g prime of 3. Well, g prime is always 3, so times 3. F prime of 7, here's f prime. 7 squared is 49. 49 minus 4 is 45. And so I end up with 3 times 7 over, square root of 45 is 9 times 5, 3 root 5. And so 7 root 5 over 15. 7 root 5 over 15 isn't one of my answers, and I feel sad, and now I have to go find my mistake. Okay, that's what happens when you go fast. Luckily, it's multiple choice, and so my answer has to be there somewhere. Okay, so I like what we said before about f of g of x, and then is y, and y prime is f prime of g of x times the derivative of the inside function. Okay, and so f of x is given to us as square root of x squared minus 4. Therefore, f prime of x is going to be 1/2 x squared minus 4 to the negative 1/2 times the derivative of the inside function, 2x. The 2's cancel. This goes on to the bottom, and I get x over square root x squared minus 4. G of x is given to me as 3x minus 2. So g prime of x is 3. Now I want f prime of g of 3 times g prime of 3. G of 3. 3 times 3 is 9. 9 minus 2 is 7. That's f prime of 7 times g prime of 3 is 3. Well, all the work I had done before must be correct, but it must be finding f prime of 7 that I made a mistake. So let's see what happens here. 7 over square root 49 minus 4 is 45. Times that 3. And then this is 7 over 3 root 5 times 3. The 3's cancel. We get 7 over root 5, which is choice A. A for number 14. 15 comes later. Here's 16 first. 16 says, A particle moves along the x-axis with position given by x of t equals t minus a, t minus b, where a and b are constants. For which of the following is the particle at rest? Well, I want to find the derivative of this to find when v equals 0. I mean, I guess I could be very algebra-y about this, because this has at a and b. And so where is that maximum, that place with the 0 slope, going to be? That's going to be halfway between these. So a plus b divided by 2 is the location where the particle is at rest. And that's choice B. But we could also take the derivative of this and then set the derivative equal to 0, and we would come up with this value. I think because I'm a little pressed for time today, I'm just going to leave it with the algebra approach and move on to 15. Okay, differentiable function h equals the integral 0 to x of f of t dt. We've got this graph shown above, and what do we know? H prime equals the derivative of this, which is f, which is the graph. So I'm given a graph of h prime, and h double prime equals f prime, or the slopes of the graph. Okay, and so I want to think about at 6. At 6, f of 6, so h prime of 6 equals 0, because that's f of 6. The slope here is positive. The slope of f, is positive, so h double prime at 6 is greater than 0. And remember how this function is defined as the integral from 0 to 6. The integral from 0 to 6 is going to be less than 0, so h of 6 is less than 0. So that's the smallest one, that's the next biggest one, that's the very biggest one, and that's choice A for number 15. Yes. Okay, 17. We're on to the next page. All right, 17 says, figure shown, integral of f equals 2 to x g of t dt, and which of the following, and this is a graph of f, this is f. Okay, and f represents the, so f of x minus f of 2 equals the integral from 2 to x of g of t dt. So my brain is not firing for this one. 17. Let's see. Well, oh, duh. This is FTC1. So, here's how I know this. I know that if I take the derivative of both sides, f prime of x equals point g of x. So, g of x is going to be the derivative of f of x. The derivative of this is a constant, right? This is a constant slope here. The slope here is a positive number, and so I'd say choice A, because I have a positive slope on the graph of f. Therefore, g, the derivative of f, must be this positive slope thing. Okay. 18, the limit as h heads to 0 of ln of 4 plus h minus ln of 4 over h. So what some of you have forgotten is the limit definition of the derivative. You're supposed to actually recognize this as the limit definition of the derivative where f of x equals ln of x at x equals 4. So this is asking what's f prime of 4, given that f of x is ln of x. So f prime of x will be 1 over x, and f prime at 4 is going to be 1 over 4, and that's choice B. But if I don't remember my limit definitions of the derivative, I'm probably just staring at this problem and thinking that it's going to be non-existent because I get 0 over 0. So don't do that. Go back and review your limit definitions of the derivative. Okay. 18 was that one. 19. 19 says f is defined as x over x plus 2. What points on the graph of f have the property that the tangent line of f, so f prime, has a slope of 1/2. And I'm looking for where this could be true. So I think I need to find f prime, which means I need to use the quotient rule. So f prime is going to be low d high minus high d low over low squared. And I wonder when this is equal to 1/2. Well, I'm going to tidy up the top. X minus x cancels, and I'm left just with 2 over x plus 2 squared equals 1/2. I'm going to cross multiply and get 4 equals x plus 2 squared. We know that's x squared plus 4x plus 4 equals 4. We'll subtract 4 from both sides, and we get this. When is this equal to 0? X plus 4 equals 0, when x equals 0, or x equals negative 4. So I get 0 or negative 4, and I see that choice C looks appropriate here. C for number 19. Okay, the next problem is 22 for some reason, instead of 20, 21, and then 22. So let's go with 22. 22 says f of x equals ln of x over x. What's the absolute max of f of x? So I want f prime, which is low d high minus high d low over low squared, which is x minus ln of x over x. When is f prime equal to 0? When x minus ln of x equals 0. And that happens when x equals ln of x. If I exponentiate, does that help? X equals e to the x. Yeah, I don't feel like that helped. So what can I say here? And this is without calculator, huh? Alright, so I've got e to the x, I've got y equals x. Yeah, I can't find that. I guess I could plug some numbers in. If this were 1, that would be e. If this were 0, this would be 1. If this were, yeah, no, do they intersect? I guess is my question. I know I'm not supposed to reach for the calculator, but I'm going to reach for the calculator. I'm going to turn the calculator on first and graph e to the x, and I'm going to graph y equals x, zoom 6. They don't intersect. So they do not intersect. How am I supposed to know they do not intersect? Huh. Certainly not because I just don't know how to do it algebraically. That's not a good reason. Yeah, that's interesting. All right, so what do we see here with 22? This function is never equal to 0. This function is never equal to 0. This function is undefined at 0. The derivative is never 0. The derivative is always, this number will be bigger than that number. So the derivative is always positive. F prime is greater than 0. It means this function is always increasing. Always increasing. And so I don't think this function has a maximum value. But my notes say choice B. Wow. Choice B. I want to take a look at those notes. What do they say? They say Mr. Kukla did the derivative wrong because he forgot the squaring here. Okay, I forgot the squaring there. And what else did I forget? Oh, this makes not that, but that. Oh, it's good to be awake, isn't it? Alright, let's try again. F prime equals 0 when 1 minus ln of x equals 0, or when ln of x equals 1, and that happens when x equals, yes, 1, when x equals e. So I make my f prime sign chart, and I put e on it, and I'll check something over here, and something over here. And if I put in a 1 here, I get 1 minus ln of 1 is 0, 1 is positive, and positive, so I have positive. If I put in an e squared here, I can bring down the 2, and I'll have 1 minus 2 ln of e over e to the 4th. Ln of e is 1, 1 times 2 is 2, 1 minus 2 is negative, divided by positive is negative. And so I have a max at e if I do my math properly. Yes, simply, I did the quotient rule right, but I just blew the simplifying. So don't go too fast, huh? Okay, 20 is next. 20 says f equals 2x plus 1 to the third. G is the inverse of f. What is g prime of 1? We know that f of 0 equals 1, therefore g of 1 equals 0. F prime is 3 2x plus 1 squared times the derivative of the inside function 2. F prime of 0 is 3 1 squared times 2, or 6. Therefore, g prime of 1 will be 1/6, or choice D for number 20. Choice D for number 20. 21. 21 says y equals 5 is a horizontal asymptote on which of the following graphs? Alright, so horizontal asymptote is the limit as x heads to plus and minus infinity. And here they're saying that horizontal asymptote is 5. So we're wondering in which of these cases is the limit as x heads to infinity going to be positive 5. Okay, here the limit is infinity. Here the limit is sine 5x over x. I get a constant over infinity, that's 0. Here I have a vertical asymptote at 5 and a horizontal asymptote at 0. Here I have the degree on top and the degree on the bottom are the same ratio of leading coefficients. I get negative 5. I don't want negative 5, I want positive 5, and that comes here in choice E. 20x squared over 4x squared is 5. And so E for number 21. 21 is E. How about 23, which I can't find? There it is. Okay, 23 says P is the population at time t, which of the following describes linear growth in the size of the population. Okay, so what they're saying here is you've got dp dt equals stuff, and when we integrate this, if we do our separation of variables, dp equals dt, and then we integrate both sides, Which of these situations is going to give us p equals linear? Well, I know the antiderivative of a constant is a linear function. And so I want to say choice A. Choice A is going to give me that. And that's 23A. All right, dp equals 200. 24. G is defined as x squared e to the kx. For what value of k does G have a critical point at 2/3? Okay, so let's find G prime using the product rule. 2x times e to the kx plus x squared times k e to the kx. Let's factor out the e to the kx, and we're left with 2x plus x squared times k. And we want to set this equal to 0. So that'll be, this is never equal to 0, G prime. So we just have to worry about this. 2x plus kx squared equals 0. If I factor out an x, 2 plus kx equals 0. And they said a critical point at 2/3, didn't they? Yes, critical point at 2/3. Well, this is x equals 0, so this one must be 2 plus k, 2 plus 2/3 equals 0. So 2/3 k equals -2. Multiply both sides by 3/2, and I end up with k equals -3. And that's choice A for number 24. Choice A. All right, 25. 25 says solution to the differential equation dy dx equals 2 sine x. Dy equals 2 sine x dx. Integrate. We get -2 cosine equals y, and we've got a plus c, and an initial condition was pi equals 1. So -2 cosine pi plus c. 1 equals -1 times -2 is 2. So c must equal -1. So y equals -2 cosine x minus 1. Okay, -2 cosine x minus 1 is choice E for number 25. 26 says g prime equals the integral from 0 to x of e to the minus t squared dt. Which of the following must be true on the interval 0 to 2? Okay, so this is g prime. G double prime must be e to the -x squared. What about the antiderivative? Do I know? Well, I don't know. What do I know? This is always positive. It's exponential decay, but it's always positive. So I know that g is concave up. And what about this integral? Well, this curve is the Gaussian curve. And we know that this curve is always above the x-axis. And so if I integrate this curve, that integral is always positive. So g prime is greater than 0. So g, therefore, g is increasing and concave up. Oh, that's very interesting. So that's choice A for number 26. And yes, A for number 26 for those very reasons. All right, 27. 27, x plus 2y times dy dx equals 2x minus y. Find the value of the second derivative at 3, 0. Okay, so dy dx equals 2x minus y over x plus 2y. Now when I go to find the second derivative, I use the quotient rule, low, d high. The derivative of this is 2. The derivative of that is minus dy dx minus high, 2x minus y, times d low. The derivative of this is 1, plus the derivative of 2y is 2 dy dx. Remember that all of this is over low squared. Okay, so in order to evaluate this second derivative at 3, 0, I need to know what the derivative is at 3, 0. dy dx at 3, 0. So let's figure that out. 6 minus 0 is 6, and 3 plus 0 is 3, and I get 2. Alright, so let's plug stuff in. We've got 3 plus 0 times 2 minus 2 minus 6 minus 0 times 1 plus 2 times 2. So that's times 5. All over 1, 3 plus 0 is 3 squared is 9. This is going to be 0 minus 30 over 9, or minus 10 over 3. And that's choice A. Choice A for number 27. Yes, and finally 28. 28 says for t greater than or equal to 0, position is given as sine t minus cosine t. Okay, and when is the first, what is acceleration when the particle has velocity equal to 0? So v of t equals cosine t plus sine t. And when is this equal to 0? Well, velocity is equal to 0. Cosine t sine t, when cosine t equals negative sine t. And that happens when the numbers are opposites for each other, and that's going to be at 3 pi over 4. The sine is positive, the cosine is negative, or 7 pi over 4. We want the first time that happens, and we want acceleration at that time. So let's come back and find a of t, which is the derivative of v of t. The derivative of cosine is minus sine. The derivative of sine is cosine. And let's evaluate a at 3 pi over 4. So I get negative sine 3 pi over 4 plus cosine 3 pi over 4. This is root 2 over 2 with a negative in front. This is negative root 2 over 2, so I get negative root 2 over 2 plus negative root 2 over 2, which is 2 of those negative root 2 over 2's, or negative root 2. And negative root 2 is choice A. All right, the last problem was A. So those are all the without calculator. Now let's do the ones with calculator. So 76, and we're told we have 50 minutes for 70 problems. Let's go. We've got this figure to the right. F prime is positive and increasing. F prime is positive and increasing. F prime greater than 0 means F is increasing. F prime increasing means F double prime greater than 0, which means F is concave up. I'm looking for increasing and concave up, and that happens at E. E for number 76. Okay. How about 77? 77 is, we've got a function on a closed interval where f of 2 equals 10, and f of 4 equals 20. It's continuous function, so IVT says that we're going to pass through all the y values from 10 to 20. And they tell us also differentiable, maybe? Nope, just continuous. And they say IVT. Okay, so f equals 13 at least once. Yes, I like choice A. I don't need to go any further because I found the one that was correct. 78. 78 says the graph of y equals e to the 10x minus 2 crosses x at one point on the interval. What is the slope at that point? So I want y prime at that mystery point. Well, let's find that mystery point by graphing e to the 10x, close parentheses, subtract 2, and we're only looking on 0 to 1, negative 1 to positive 1, because I'm looking for an x-intercept. Okay, boink, 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 boink. I don't see any crossing. I wonder if I'm in the right mode. I am in the right mode. Did I have the right function? E to the 10x minus 2. E to the 10x, second insert, close parentheses, graph. Okay, and I see I'm going to get this one point of intersection here. Second, calculate intercept, no, 0, enter. Enter, enter. And so I want to know the derivative at 0.6061193. Okay, so second quit, math and deriv, y1, comma x, comma 0.6061193. And I get 2.961. 2.961 is choice D. D for number 78. Okay, 79. Particle moves along the x-axis. The velocity is given by v of t. Acceleration by a of t. Which of the following is average velocity? So average velocity is going to be the average value on 0 to 8, 0 to 8, v of t dt, which would be, oh, but I see that answer there. Average velocity is choice B. 79B, yes, 79. 80. 80 says, the graph of f prime is given. Which of the following statements must be true? F prime has a relative minimum at negative 3. Negative 3, f prime goes from negative to positive, so I like Roman numeral 1. That's good. The graph of f has a point of inflection at negative 2. At negative 2, I go from increasing to increasing. That's not a point of inflection, so not 2. And 3, the graph of f is concave up from 0 to 4. So from 0 to 4, f prime is decreasing, which means f double prime is negative, which means f is concave down. So f is concave down from 0 to 4. So Roman numeral 3 works. And so we want 1 and 3, which is choice E for 80. E for 80. Okay. 81 says, water is pumped into tank. R of t is the rate. I wonder if I'm going to integrate a rate. Equals 31 minus e to the negative 0.16t. Don't lose that decimal point. Okay, gallons per minute. Since pump turned on, tank contained 800 at time equal to 0. How many after 20 minutes? So a of 20 minus a of 0 equals the integral from 0 to 20 of r of t dt. But remember, we're looking for a of 20, and that means we have to add a of 0, or 800, to the value of that integral, r of t dt. So I integrate with my calculator. Second quit, math, integrate 31 minus e to the negative 0.16 x, close parentheses, comma x, comma 0, comma 20. Remember, we still need to add 800 to this, and so I get 1220 approximately, and that corresponds to choice D. D for number 81. Yes. 82, is that next? No, 83 is next. 83 says the graph of velocity is shown, okay, 0 to 8. Velocity is always positive, so object is always moving to the right. We've got a car traveling. Car comes to a complete stop. Estimate the distance traveled. Okay, well, each of these boxes has a width of 1 but a height of 10. And so when I multiply 10 feet per second times 1 second, I end up with each box is 10 feet. So let's count full boxes. 1, 2, 3, 4, almost 5, 6, 7, 8, 9, 12, 13, 14, 15, 16, 17. This one plus this one is 18. I'm going to go with 19. And I'm going to say 21, 22. And each of them was 10, so that would be 210, 220. I'm going with choice D for number 83. D for 83. Okay. 82 comes next. 82 says f prime equals the square root of x to the 4th plus 1 plus x to the 3rd minus 3x. F has a local max at what? Well, I'm going to take f prime and graph it and find when f prime equals 0. Square root of x to the 4th plus 1, close parentheses, plus x to the 3rd minus 3x. And I want this, I don't know. All the values are between -3 and +2. So I'm going to make my viewing window go -3 to +2. Graph. When is f prime equal to 0? That seems to be a minimum over here in negative land, but I'm looking for a max. A max, f prime would go positive to negative, so I'm looking for this point here. Second, calculate 0. Doink. Doink. Alright, so my maximum occurs at, that looks like 0.350. X equals 0.350, and that's choice C for number 82. Okay, 84. On -1.5 to 1.5, f is a first derivative given by f prime equals e to the x to the 4th minus 2x squared plus 1 minus 2 on -1.5 to 1.5. Okay. Which of the following intervals on the graph is f concave down? So let's talk about f double prime. F double prime is going to be the derivative of this, which is e to the x to the 4th minus 2x squared plus 1 times the derivative of the inside function, which is 4x to the 3rd minus 4x. Derivative of that is 0. Now, this is always positive. So what about this? If we factor out a 4x, we've got x squared minus 1. and I see critical points at -1, 0, and 1. Alright, so let's plug in some values here. In fact, we could just graph this, right? And so we know positive, negative, negative, positive. But we have to take these values and multiply them by this always positive. So over here, negative times positive is negative. And what are we looking for? Where f is concave down. So I like from -1.5 to -1. And then over here from 0 to 1. And those don't look like any of the answers. Yes, they do. They're exactly these answers for D. Huh. 84D. Yes. How nice. I didn't need a calculator for this. Well, that's wonderful. Okay, so union 0 to 1. 85. 85 says we've got a graph here of f prime. When does f have a local max? When f prime goes from positive to negative. This doesn't have endpoints, so that's the only place we have a local max, which occurs at x equals 1. And so 85 is C. 86. 86 has a bunch of tables. F prime is greater than 0, which means f is increasing. And the integral from 4 to 7 of f equals 0. That means that there's some stuff above and some stuff below, or everything that, no, yes. And it can't be, this function is the 0 function, because the integral from 4 to 7 of the 0 function would be 0, because we know that f is always increasing. So I want an increasing function where some of this is negative and some of this is positive, and these areas cancel each other out on 4 to 7. Okay, so which must that be? A doesn't have any positive y values. D doesn't work. E doesn't have any negative y values. So now I'm just checking out B and C. Okay, so let's think about this. C goes from -4 to 6, but then from 6 down to 3. 6 is increasing and then decreasing, so that doesn't work. So our only choice is B. B for number 86. Okay, 87. 87. Ooh, we're almost done. 87 says we've got the graph of f double prime shown on -2 to +4. Okay, so here's that graph. And this is 1, and this is -1, and this is 3. And they want to know when f is concave down. F is concave down when f double prime is less than 0. And so I'm going to say, whoa, I want x values that are less. Oh, this stops here, right? So on -2 to -1, union 1 to 3. And that corresponds with choice E. E for number 87. 88. Person whose height is 6 feet walks away, straight line. Hey, this sounds like one of those related rates shadow problems. So there's their shadow, and that's x, and they're 6 feet tall. And if the height is 15 of the lamp post, okay, the rate at which the person's shadow is lengthening. They want to know ds dt. Do we know how fast the person is walking? Yes, the person is walking away from dx dt is positive 4. Alright, so can we write an equation that relates these things? And yes, we said shadow problems were usually similar triangles, and so we're going to write a proportion. This is to this, as this is to all of this. And so let's cross multiply and get 6x plus 6s equals 15s, or 6x equals 9s. And now let's take the derivative of both sides with respect to time. 6 dx dt equals 9 ds dt. We know dx dt is 4, so we're going to do 6 times 4 divided by 9 equals ds dt. These cancel, 2, 3, and I get 8/3. 8/3 is 2 2/3, and that's choice B. B for number 88. B for number 88. Okay, problem 89. What's it say? Particle moves along the line so that a of t equals t plus 3 over square root t to the third plus 1. If the particle's velocity is 0 at at 0 is 5, v of 0 equals 5, what is the velocity at 3? Well, so then v of 3 minus v of 0 equals the integral of a of t dt from 0 to 3. So let's add v of 0 to the value of this integral. V of 3 is going to be 5 plus the integral from 0 to 3 of a of t dt. We'll use our calculator to find the integral of a of t from 0 to 3. So math integrate. Math integrate. Don't forget parentheses around all the stuff up top. X plus 3 divided by parentheses. Actually, everything's in that radical, so square root of x to the third plus 1, close parentheses on that radical, comma x, comma 0, comma 3. Don't forget we still need to add 5 to the value of this integral, and so I get v of 3 equals 11.710. 11.710 is choice E for number 89. 89 is E. Alright, what about 90? 90 says f is defined such that 6 to 12 of f of 2x equals 10. Which of the following must be true? Okay. F of 2x equals 10. Well, I kind of want to do a u sub here because I'm troubled by this. So let's say u equals 2x. So then du over 2 equals dx. So this can be rewritten as f of u du over 2, or 1/2 integral f of u du. Now, what about some u bounds? Let's take these x values and plug them in. So 6 times 2 is 12, and 12 times 2 is 24. So 1/2 the integral from 12 to 24 would equal 10. Well, I'm going to multiply both sides by 2 and get 20 equals the integral 12 to 24 f of u du. 12 to 24 f of t dt equals 20 is choice B. So B for 90. And our last problem, number 91, f is a polynomial function with f prime values given here in the table above. Which of the following must be true on -2 to 6? So I see f prime goes down, then goes up, and goes up some more, and then down a little more. This is what f prime is doing. So, and all of these values are positive. So f is always increasing, but increasing and concave down, increasing and concave up, increasing and concave down. So I've got 2 points of inflection here. The graph is concave up, not always, no. Has at least 2 points of inflection. I like that. F is increasing. Don't I know that because all these values are? Well, so here's the thing. I don't know, just because they've given me these selected values, I don't know that this function is always increasing. So when I have 3 and then 1 and then 4, I could actually have come down here below between -2 and 0. So yeah, I can't say that this function is always increasing. So I'm going to go with this function has at least 2 points of inflection. 91 is B. All right, there's AP Review Packet number 14. I hope this was helpful. Have a great day, everyone.